Let's look at central angles and inscribed angles. So I have a couple pictures here, a couple circles that show what a central angle and inscribed angle are. So central angle, just as a reminder, is an angle where the vertex is at the center of the circle, the very center. Inscribed angle is where the vertex touches the circles on the circle. So what? So what about them? What's special about them? Well, one special thing about a central angle is if I know, let's say this arc here is 98 degrees. Great boy bands of all time. So this central angle would also be 98 degrees. This angle is the same as the intercepted arc. For an inscribed angle, let's say this is 100 and looks like it's about 164 degrees is my guess. The inscribed angle is half. It's always half of the intercepted arc. So this would be 82 degrees right there. Okay, so what I did was I figured let's look at a few examples and make sure we get it. So I have 6 examples here. If I have this arc AB is 90 degrees, the question that would most likely come up is what is angle M? Well, we just talked about this. The arc is the same as the central angle, so this would be 90. And vice versa. If they give you the central angle, you can assume that the arc is the same. Okay, if this is 160 degrees, this arc from C to D, then half of 160 would be 80. So if you're watching this for notes purposes, what I would encourage, I probably should have said this before I went over these two, is maybe pause it. I'll scroll down slightly so you can see the others. Copy them down and see if you can figure out like the missing angles and arcs on these shapes. Okay, this angle is 70, so what would this arc be right here? Well, if this is 70, we just talked about this, the angle is half of the arc. So here we divide it by 2, but if we know the angle, we're going to multiply by 2. So 70 times 2 is 140, maybe about 140. All right, here, the bottom one, we have an arc, and we got some funky looking quadrilateral happening here. So one question would be, what's the central angle? Well, it's the same as the outside arc, so 100 degrees. Another question would be, what is the inscribed angle? Well, if this is 100, this would have to be half, so 50 degrees. Another question would be, well, what is this angle and this angle? And the answer is, I don't know. There's really no way to tell without more information. They look like they're about the same, but they're not necessarily the same. So we can only find these two. A third question, or I guess fourth question, might be if we want JKL, if I asked you for this JKL, that would be how much? Well, remember a circle's 360. So if this is 100, that means from J to K to L would have to be 260 because 360 minus 100 is 260. Okay, so this time you're given the inscribed angle, and if I extend out these lines, N to P and N to Q, if this is 40 degrees, that means this intercepted arc here has to be twice that, so this would be 80 degrees. And then this central angle would be 80 degrees. Obviously, it's obtuse, so it's not a great drawing, but this is how the math would shake out. Okay, so what we're going to find on this one is we're going to figure out what this angle is. We're going to figure out what this angle is. We're going to figure out what this arc is and what this arc is. And we could probably also figure out these angles here. We'll do that. So let's start with this arc, SX. If we start at V and we extend out our lines here for angle V, I guess this would be angle XVS. This is 20 degrees. And that means that this arc, SX, is the intercepted arc for this 20-degree inscribed angle. So this would have to be 40 degrees because it's twice as big as the inscribed angle. Sorry about the bell. So let's clear this out. And then if we want to do the same thing for this, if this is 30 degrees, we extend that out, this would have to be 60 degrees because it's double that. Okay, so I'm going to clean this up again. So then a question might come up with, what is this angle right here at T? Well, if you look, this angle at T, the intercepted arc is 40 degrees. So the inscribed angle would have to be half of that, which is 20. And then likewise with this angle, if you're asked to find, whoops, I got a little bit excited there. Let me clean this up. If you're asked to find this angle here, well, the intercepted arc would be 60 degrees, so this would be half, which would be 30 degrees. And then, like I mentioned earlier, if we wanted to find this angle, we have a triangle here. So if this is 30 and 20, that's 50. We know these three angles in a triangle have to add up to 180. So 180 minus 50 would be 130 degrees. And then you could figure out the other three because we have some vertical angles here. So this is 130, and we'd have 50 and 50 here and here because 130 and 50 are a linear pair, so they have to be supplementary. Okay, so there's a few examples of central angles and inscribed angles.